Hello, everyone. My name is Zach, and over the last 10 days, I ran an experiment in public. Can background agents run an entire software development lifecycle and not just write code? The idea was pretty simple. Instead of using agents as a one-off coding assistant, we wanted to see what happens when you connect them into a full operating system for software delivery, covering planning, implementation, review, deployment, monitoring, bug triage, the metrics, the documentation, everything running continuously in the background in a secure cloud environment on ONA. We did this with one major constraint, no human written code at all. Our product called Memo, which is a Notion style note-taking app, was supposed to be built by agents entirely, where the human only steers the spec and the vision. What I'm going to share today is a field report about the state of the software factory, what worked well, what didn't work so well, how we set things up, what surprised us, and most importantly, how this shapes my view how software development is going in the future. So most agent demos today show one thing: agents are great at code generation. You give the agent a prompt, it writes some code, maybe it opens a PR, then usually the human reviews it, or you have a code reviewer, but there's typically a human in the loop. So this is quite useful, but it only covers one part of shipping software. If you think about software delivery as a whole, it's much broader than just writing code. You need to decide what to build, break it into work, implement it, then you review it, you test it, you deploy it, you continuously monitor, and ultimately you feed that back into your planning stage and shape your roadmap. So the question is, can background agents cover the entire loop and ultimately build this factory? And a factory is naturally not a single prompt. It's a system. It's a set of processes that keep running even when you're not there, when you're sleeping, and really continuously 24/7 churn out the work. So in 10 days, we wanted to see how far we can go. We set up a cadence of daily live streams, building everything in public, designing our spec, setting up our automations, and then letting the factory go and build out what we wanted to build. So again, as I said before, the product is called Memo. It's a Notion-style note-taking app. We chose that because it's complex enough to be real, right? You need authentication, you need workspaces, text editing, databases, which we added in the second week, search, feedback tool. There's all the use cases around deployment, and you can actually run everything online, get some feedback, and this is why this made it a great app to see if this works. If you're interested in going deeper, we have all the live streams online. So if you have some time, feel free to go through the streams. Otherwise, I will be summarizing now where we got to. So within the first 10 days of working the factory, merged over 375 PRs, which I think is a really, really cool number to see. Produced just under 68,000 lines of code, generated over 1,000 tests, and I think by now we're over 2,000 tests. Ran across 16 background automations. We, again, added a couple ones as we went along. So now the number has even grown further. However, the operational numbers are what I think were really, in my mind, just blown. If we look at the issue to close time, we have 38 minutes median. The PR open to merge time, under 5 minutes, which is insane. And then 87% of all PRs were merged autonomously without the user taking any action here. Also, if you look at the number of agent executions, 98% of them were triggered completely by the factory without any human in the loop, which is mind-blowing to see. So there's a real gap still between agents can write code and agents can ship software. And the goal of the factory is really to close this loop from just churning out code and looking at the entire pipeline and how we can progress from just writing code to building a product and then feeding this product back into the planning stage and letting agents improve over this loop. I think it's really interesting to see what happens when you have events triggering automations, if you have product feedback coming in, both from bugs as well as from users themselves. And that really kind of shifted our view on how to set a factory up. And as you can see, we divided our automations across the different stages of the SDLC. In total, you can see around 22 nodes here across our automations, across where the human input comes in, across the third-party tooling that we leverage. And you can pretty much group them across the planning stage, the building stage, the review stage, deployment, which we use the third-party tools here, Vercel for hosting, and obviously GitHub Actions for CI. And then naturally, you have a large cluster in the operational phase that is intended and really focusing on reviewing everything that goes out into production, catches any bugs, any incidences, monitors the performance of the database, and then feeds it back into the planning stage, opening issues if that needs to happen. To quickly run you through how basically the building process works, initially there's human input, right? You come up with a spec. This spec feeds into the feature planner. Our feature planner is, I think, a very interesting automation. It does a lot of heavy lifting. It breaks down the human steering into a spec. It enhances it, so you can give it, a 5-liner. It breaks it down, adds more detail, asks for a question if it needs more input, and then ultimately hands over to our feature builder. The feature builder then builds out the feature, compares it to the spec, compares it to the acceptance criteria, and really continues to work. We've seen, a couple of these feature build-outs taking a couple of hours in order to implement. And once the acceptance criteria is met by the builder, we then go into the PR review, which does another loop, checks if all the criteria is done, and then either closes the issue or goes back into the planning stage to make adjustments before it goes into deployment. So we really see this is not just a single agent. This is a network of different automations going through, and they can be triggered in different ways. We have a mix of different triggers. So, for example, our review, naturally for PR reviews, is an event whenever there is a PR opened or updated. And then we have the PR merge, which triggers a verification, just smoke tests the live app, makes sure that no bugs are introduced. And even if they are introduced, we can then open a bug issue that is picked up by the bug fixer, or we continue with the next issue through the feature builder. Then we have some time-based automations, like the incident responders, which scan Sentry every 15 minutes. So we set up Sentry for monitoring and have our incident responder monitor the list of bugs, classifies them, triages them, and if they are if they require action, then they go back into our feature builder or bug fixer. And naturally, we have some operational automations as well that helped us maintain our Twitter, for example, that collates the daily metrics, drafts tweets, and then we have some other automations which are part of the self-improvement loop, like the automation auditor that reviews our automation runs, reviews our prompts, and makes suggestions where to improve, which is super cool to see. Maybe to dive quickly into the feature builder, go a bit deeper into what it does and how it does what it does, and we'll take a look at the YAML as well in a second. But to just quickly run you through how it structures its work, it basically uses GitHub Actions, the GitHub issues list to find its work and checks for open bugs. So bugs always come first. So the bug fixer, if there's any P1 bugs, goes to work first. The feature builder basically blocks until there's any no high priority bugs left open. It then continues down the backlog list to find features it should build and implement. It reads the acceptance criteria. It reads the MD files, like the agents MD, the architecture, the conventions, the design file, which is really like our main harness for this loop, right? We have a extensive documentation around the repo structure, our conventions, how we should work, how we should keep track of documentation. And this is really like the framework and the harness where the feature builder operates. It explores the code base, so it is really familiar where it should place any kind of new code if it comes up with new conventions that are not covered yet, how to document them, and then has a predefined order in which it should implement, from migrations to types, data, UI, and then tests at the end. I think also it's super cool to see that we have the testing phase here as well. So you write your tests end-to-end, unit tests, implementation tests, and it worked really well, as we can see in the metrics as well. And the dashboard is online, so you are able to see that as well. Naturally then goes into the verification loop, checks the acceptance criteria. And when that's done, it opens a PR, references the issue number, and the PR reviewer takes over. So we really have a loop that there needs to be an issue that the PR that needs to close, unless it's a issue that was raised by a maintainer or by a human, then we skip this phase of having to reference an issue. But this is just like another safety net to help us maintain an audit trail. Obviously, it's also important to look at the failure path, right? Sometimes the agent work doesn't complete, and we also need to account for this. The most important thing is that we don't fail silently. So the loops that we utilize here is if the agent encounters something it can't fix, it leaves a comment, it adds a label, needs human. You can see that on the repo as well. I'll show that in a second. And that then requires human action to go in and to either make a fix or leave a comment or start an environment and owner and action this. And then it typically returns the issue to the backlog for the next automation run to pick it back up. We have a couple of fail-safe automations as well in case an agent run goes stale and doesn't exit with any of these actions. That reviews if there are stale issues or stale PRs, and then goes in to fix these. So let's quickly take a look at the YAML. And as I said before, the PR and the repo is completely public. So you can go in and explore the structure, how we set things up. If you have any questions, please feel free to reach out and we can explain what I did here. But as you can see, our feature builder works both on a cron as well as on the pull requests. As I explained just now, it has a structure where it first does some pre-flight checks, checks the environment health. It then goes through the backlog. Again, it's instructed to work with agent conventions, with the label conventions that we set out. So we have priority, we have the type of issue that we are looking at, the status, which is quite important. So we use backlog for everything that needs to be picked up. It's also instructed to not pick up anything that's in progress to avoid two agents doing the same kind of work. And then reads the issue body, checks dependencies. So we can also run work in parallel, making sure that all upstream dependencies are solved before a new piece of work gets picked up. If it depends on a previous issue that's not yet closed, it then gathers the context, explores the code base and what exists, then plans the approach, goes into building mode, and then follows the rules. At the end, we have the verification step, which it runs through as well, and then naturally updating our knowledge base. So as you can see in the agents folder, we obviously have a README for the repo itself. Then we have the architecture file, which lays out how we structured our repo, where code should sit. We have our conventions, which really go into how we want to structure our code, what should be server components, what should be client components, and our preferences here. We have the design file, which was our initial design spec, and I'll touch base on that in a second, and a quality file, which is part of the harness as well, which helps us self-improve the app. So maybe quickly to demo what we've built. Memo is online, so you can try it out yourself, but it is a fully functioning app. So let me just quickly log in here and show you around what we've built, or what the factory has built. So the workspace should look fairly familiar to you if you've used Notion before. We've given it a bit of a twist on the design, make it a bit more edgy with hard edges. But yeah, you have tests, test pages in my case here. You have an editor that you can write into. We have databases, which I think is a really cool feature. So the databases actually work. You can embed your databases that you create with different views. We have calendar views, we have board views. The agent makes use of caching. So after the initial load, which as you could see took like a couple of seconds to load everything, and then gets a lot more snappier. We've added a feedback tool that lets you report any bugs of product feedback directly in the UI, including a screenshot that you can attach. And this is actually connected to another automation which compiles user feedback into a Slack channel, where then the product team can action it directly, which is, I think, a really, really cool feature. all the settings that you would expect from a tool. Workspace settings, you can create another secondary workspace or a third workspace if you want to share with your team. We have obviously team management, so you can manage who can access your workspace as well, and a theme selector just to make sure that we have a switcher here, and the keyboard shortcuts. You can also navigate the side without having to use your cursor. However, I actually prefer to use the cursor. Yeah, so if you are interested in giving that a spin, it's online, memo.software-factory.dev. Then let me just go quickly back to our presentation. Yeah, so we took a look at that. I think some things to highlight where we really saw the development take off was after day 2. So day 3 is when we were kind of happy with the spec, and we went into building mode. Basically overnight, the first product was implemented. There was like 54 PRs in one day. Went from scaffolding the app to a full functioning app. You kind of saw the first iteration of this factory really churning out work, which was super cool. Then on the weekend, it was really great to see because the factory burned through all the work that it had according to the initial spec, and then it started to do some self-improvement work. So it caught some bugs. It saw some gaps in the initial implementation and improved in itself. And then on day 7, when we closed the full operating to planning loop, while we had kind of the bug monitoring already in the app, we added the feature requests and the feedback toggle in the UI, so we could gather user feedback and add more features. So for example, the database view was something that was not in the initial spec, but we added after the initial build out, but also based on user reviews saying, hey, this is a feature that we are still lacking here. I think if we look at the challenges that we're facing with Software Factory, it's pretty much taste, right? We can boil it down to taste, and we can look at it from a way that this is the hardest thing to get right. The product that the factory turned out initially was functional, but felt quite generic. Naturally, if you look at the UI right now, I wouldn't say it's a very fancy UI, but like we've done some work to give it a little bit of a look and feel, and it feels like a coherent product, which I'm quite proud of. But it is something really where we can see this is where agentic coding and software factories still have a gap. Also tried a couple of different tools. So as I mentioned before, we had the DesignMD file initially kind of as a guideline, how the product should look, how it should feel, and it worked somewhat well. But we hit a ceiling, I think, quite early on. So there were some contrast ratios that were not quite right. This is actually something I tried Claude Design with, and it fixed the contrast ratios. But while it fixed the contrast ratios, everything kind of looked the same afterwards. So you can see that like it fixes things, but it doesn't go the next step and think about, okay, what makes this design really tasteful and great. And I think this is something where the human is still required. So another fix that we added is actually using Storybook, putting our design system into a visual reference that the agent can go into and compare with, which then also improved our iterations and the amount of iterations we had to do compared to just having the DesignMD file. So the product improver basically screenshots the live app and compares it to the component of the storybook, and then can really go into this improvement loop of fixing the UI before it ships, rather than shipping a UI that's buggy and not to the level that we want. But ultimately, right, it all boils down to how good is your spec. This was probably the single best and biggest learning, that spending time on spec is really worth it. Because initially, we spent about 2 days setting up naturally the factory itself, but also writing spec. I have to say, writing spec with and iterating with the agent to get the spec to a very, very high level. But the initial product spec was really in-depth and had a lot of time go into. And then basically after this first iteration, when we hit go on the factory, we got a really good output and I was really surprised with the quality. And naturally, there were some rough edges there, but this was really like a wow moment. And for example, with the database feature, this was a 5-liner, just giving the agent some instructions about the feature that we want, and then hitting go. And while it worked, there were a lot of UI bugs. For example, the date picker was cut off by the overflow. Property editing didn't really work out of the box. And then I spent quite a bit of time raising those bugs because there were UI bugs. It wasn't something that would be caught by Sentry necessarily. Obviously, if you look at the self-improvement loop and the verification, it should be something that should be caught by visual verification. But this is really something where I say, okay, spending more time on spec makes sense if you're building out a new feature rather than quickly iterating. And the more precise you can be with the instructions, the better the output will ultimately be. I think one really cool thing with the factory is that you can build in self-improvement. And this is, I think, a moment that makes you think, wow, this is really, really cool, because the factory ultimately can improve itself. We've solved this across a couple of different methods. One, we have the automation auditor. So automation auditor is another automation which currently runs once a week, looking at the automation configurations, looking at the automation runs, and then is able to make suggestions based on what it finds. For example, it can see if there's any regressions coming up and why those came up, make suggestions how to fix them. Then we have the product improver, which is I think the newest automation that I added. The product improver really has the goal to look at the product as a whole and can make suggestions on UX gaps, on feature gaps, compared to what a great product would need, without you proactively having to go in and without it just being focused on fixing bugs. So it's really like a gap analysis, if you can look at it from that point of view. And then we have a quality MD file. This was there from the beginning. This is basically a self-grading report card for the agent to go in when the backlog is empty. The feature planner can read it. It can create issues if it sees any regressions, if it sees any gaps there. I think the caveat, and we mentioned this in the stream before, is the agent is sometimes very lenient on its own quality and maybe grades itself too highly compared to if you were to go in and look at what it did. Obviously, time into factory is another factor that makes this approach so powerful, right? At the beginning, you have to spend a lot of time setting up the factory, and I felt that. There's a lot of time kind of where you focus on the individual loops, on the individual automations, sense check if the output works. You need to supervise it. As you progress, time spent on that really tapers off significantly, and your focus really shifts onto product. Does the product work? And you can define the vision for the product much more. So you don't necessarily have to think about the product as in like the feature by feature details, but you can really focus on the vision of the product. And as an engineer, you obviously switch from building the main product to building a factory, and that also kind of shifts your time, because once the factory is running and then you have the self-improvement loops going on the factory, that time spent also becomes less, and you just need to focus on kind of verification and being ultimately the fail-safe. But if you think about it, you really move from in the loop to onto the loop, which is incredibly powerful. I think if we reflect and if we had to start over, a few things I would change. So most importantly, our improvement loops. I only started them at the end of week 1. I would probably start them earlier, as soon as the product goes online first. While the automations are not necessarily perfect when you launch them, you then have the ability to go into the automation auditor and the improver to review what they're doing and get those suggestions. So while you don't necessarily have to action them, it gives you another perspective. Then obviously, Storybook is an important part. You want to add Storybook, I think from the beginning, spend some time on the design system. Again, this is kind of ties into speccing the product, which is the next point, you really just want to spend as much time as possible speccing the product, and then you save yourself a lot of time debugging and iterating on any bugs. And speaking about bugs, any error that you encounter, you want to make sure is highlighted and not swallowed by the system. So this is probably something to highlight also in the product spec, to make sure that any error that is being caught can be caught also by your systems, because the more data you have, the easier it becomes to iterate and then ultimately close this operations to planning loop as early as possible. Get users onto the product as early as possible, because you can test it yourself. But the most powerful feedback is coming from actual user actions, and you'll see a lot of edge cases come up from that. I think if you want to start building your own factory, just get started. The most important thing is you don't need to build a full factory from day one. You can literally start with an automation, right? Most of you might already work with PR reviews. This is like super easy to close. Get PR reviews, get comments generated by the agent and actioned. You then work across the harness, building a better ND file, building better automations as you go along. You build up layers as you build up your factory, and then you think about the loops that you want to close, right? Obviously, the most important one to close, I think, is still operating to planning. How can you get yourself into a position where you can spend more time planning and less time worrying about your operations side? I think it's very powerful if you can just look into your operations side and you can get the metrics from the agent rather than having to spend the time yourself. And then obviously let the agents fail visibly. Make sure that your agents fail visibly and not silently, so you can improve them. This is kind of your friend is visible failure, not silent failure. And yeah, the next steps for our factory are pretty much letting it run. We'll see what happens when we walk away now. Maybe in 30 days, maybe in 6 weeks, seeing where we get to when there's real user usage, when there's a real product running, when we have our loops firing, when we have the self-improvement, we have the feedback, and we will really see what it will build, what will break, how much autonomy we will get from this, and where the factory goes. So yeah, if you want to go build your own factory, I think it's pretty much possible today. It's super, super cool. You can choose to build it completely from scratch if you want to, or use a platform like Ona that makes a lot of this a lot easier, and you can focus on building your automations. If you want any more insights about the Software Factory, you can find everything on the website. The repo is linked there. The product is linked there. We have a dashboard with all the metrics. You can find the diagram that I showed with all of our automations, how they interact and how they interlink with each other. You can find the system prompts in the repo. So please feel free to have a go, and thank you very much.